Good evening, guys. Am I audible? Is my screen properly visible? Sorry for the delay, I just got some technical issue. Is it clear now? Good evening. Yes, good evening. How is things going, guys? In the past 3 days, we have covered many topics in AWS. So can we see a recap of what we have seen? Tell me, guys, what all topics we have covered in AWS, what all the services we have seen. Quickly, guys, we can start with today's class. So in day 1, we have seen introduction, and then we have completed AWS account creation and budget. And then on day 2, we have started with identity and access management, EC2 instance creation, virtual machine. A little bit doubt about what is the difference between EC2 and Elastic Beanstalk. I can clarify it also, which means like one of you guys have asked what's the difference between them, like whether both of them are deploying the application, what's the difference actually. So anyone remember, guys, what all the types of cloud services we have seen? In the first day I have given an introduction, what all the types of cloud services available, right? Remember? So like these services will be provided by them. It is called as infrastructure and service, and some it is called as platform as a service, and one thing is called as software as a service. Do you guys remember about that? What is the key difference between them? So when you go for EC2, okay, it is like a virtual machine which you can rent, but you are responsible for everything. They are giving you the infrastructure, but you have to configure it. You have to set what is the OS you are going to use. Okay, you have to choose what is the load you are going to have. Okay, what is the storage you are going to have. You will be configuring everything. So that is called as infrastructure as a service, right? So for platform as a service, what is platform as a service? So they are responsible for the infrastructure, along with they will take care of the OS, the auto scaling, the load balancing, etc. They will take care of it. You just have to worry about your configuration and your application code. Okay. So when you go for Elastic Beanstalk, it is platform as a service. Clear? What is the difference between EC2 and Elastic Beanstalk? So when you go for Elastic Beanstalk, you have to worry about your own code because they will take care of everything. Okay, other things. Okay, my voice is low. Please let me check it. It's working fine or not. Hello. Yeah, this is working fine. Is it audible now? Yeah. So once again, I welcome you all to this day 4 machine learning operations with AWS. We are in day 4. I think we can start with the class, right? And today we are going to start with something known as AWS Lambda. Okay, and we have some part of introductions and we have to see about it. Am I audible properly? So when you go for this AWS Lambda, there is an option. We'll see about it. What is this AWS Lambda? So what they used to tell us, what they'll advertise it. AWS Lambda is something like it is a serverless compute service. Okay, which means what is serverless? Which means there is no server. What is that actually? How can a website or thing runs without a server? We have a physical server, or if you are going to use cloud, there will be some server in their data center. Okay, so they will have it. They will have it, but what does this serverless means? So we'll check about it. So what is serverless actually? In serverless computing means the cloud provider allocates the machine resources on demand, taking care of all the servers on behalf of their customer, which means they'll take care of server. So you don't have to worry about server, about anything. So that's what they'll advertise as serverless. So when you hear anything about serverless, it is not like there is no server at all, which means if it is serverless, you don't want to worry about the server. So the service provider, the cloud service provider will take care of that. Okay, and your work will be working on your own application and whatever you are working on. So this AWS Lambda is a serverless thing. So AWS Lambda is a serverless compute service that runs your code in response to a trigger. Okay, you can make automation with this. Okay, so that runs your code in response to a trigger. When you give a trigger, it is going to respond to it and automatically manages the underlying compute resource for you. So these triggers may include changes in state or update, or you can add some other options too. So whenever you are changing something, it will automatically perform this task. So there is a great example there for using AWS. For example, see here, what you can do is using AWS, they will take care of it. What will happen is you can take a photo and something known as S3, guys. We are going to see it in today's class. It's for storage actually. Okay, we have seen about S3 in many places. It's for storage, don't worry about it, we are going to see it. So when you upload a photo to this S3, you can automate it. So what will happen is whenever a photo is uploaded, this Lambda is automatically triggered. Okay, and this Lambda, what it will do is you can write some code using Python where it will resize the photo. Like it will, like you will be having some sort of definitions. This is the photo size I should have. So that will be resized and it will be given back and stored in S3 again. So whenever you are doing it, it will automatically do that task. So this is what a Lambda, AWS Lambda use case example. Is it clear? Go back into my console and go and search for Lambda and it run code without thinking about server. So it's serverless, which means, what is serverless, guys? Yeah, this is the home page of this AWS Lambda. You can create a function here. You can go and click it. Okay, you can go and author it from scratch. I'll go with it and you can give any name. So my Lambda, and let me keep it to Node.js. You can go and select Python. If it is going for Python, you can use it, and I'll go with Node.js. And this is the architecture I'm going to use. Now I can go with create function. Okay, I think there's issue something with my video, so please wait, I'll try to sort it. Is my screen visible now? Dear participants, can you please confirm whether it's working or not? Now I think it's fine, right? Yes? Yeah, so I think we can start with the class again. Sorry for the issues, some technical issues with the internet. So we'll start with the class, okay? So I'll continue once again with AWS Lambda. So see here, Lambda is something like serverless computing, okay? So what does mean by serverless? Is it like no server? No, okay? Serverless means server will be taken care by them. Okay, you don't have to worry about the server. So this is what known as serverless. And in Lambda, what you can do is actually you can create a trigger. For example, I can automate using this AWS Lambda. If something happens, I can use this. Okay, like this one. For example, if I have a photo, this S3 is for storage, we are going to see about it. Okay, if I like upload a photo, I can automate it. Whenever a photo is uploaded into this S3, a Lambda will be triggered, and what it will do is it will run the code. So if I have a code for resizing like an image, okay, for example with Python, if I resize it, okay, it will be resized and it will be stored again. So this code will automatically run it and you don't have to worry about it. So that's what the use case of Lambda. So what we are going to do now is we'll go hands-on and try to create once again about the Lambda function. So can we do it, guys? Can I get thumbs up? Is it okay now? Is everything fine now? Am I audible? Screen are clear, right? So we'll go and click this create function actually to create it. So when you go into Lambda, this will be your dashboard. You can go and create a function. Okay, you can give a name, you can author it from scratch. So I'll give like my Lambda. Okay, so it is Node.js and we can go with it. So you can select Python if you want. I'll just go with Node.js now. Okay, I'll create the function. So it will take some time to create actually. Yeah, now it's created, and what you can see is it is giving me add a trigger, and it will go to the Lambda, and finally you can add a destination. Like for example, if you add a trigger to S3, okay, what I have told, S3 is a storage option, right? If I go and select S3 like this one, you can have many options for this trigger. If I go and select this S3, what it will do is it will use that S3. So something happens to S3, if a file is like created, it will go into that Lambda function and perform that task, and you can add a destination to have your output file. Okay, so what you can do for checking, okay, so you can go and use this test, and you can go and see the code here. So you'll be having a sample code, okay, Node.js code. So what we are going to do is, if you want to test it, you can have, if you choose Python, you can have your Python file here and you can edit it. So this will run automatically. That's what the Lambda will do. So if you want to run and check it, you can go into the test and you can configure a test event, okay, just for testing. So test 1, I can give something like this, okay, and this is the JSON file, which is the key value pair which I am going to enter it. So instead of this key 1, key 2, key 3, let me give something like, for example, we are just going to check whether this is working or not now, okay. So I'll give something like products, and the product value is TV, okay. So I'll just save it. So this is a test case, and we want to alter this code. So don't worry about it. We are just going to check whether this is working or not. If you don't know about this, you don't have to worry about it, okay. So I'll just go and take constant, okay, product equal to, from this event, okay, I can get that product which I have created, event dot product, okay. And here in the body, I can take this hello, or I'll just give like information. So what information we have given there? Product, right? So I'll go and get the product. So it should give me a answer like what it is. It will be TV, right? So you can, what you can do is, once you have your changes, you can go and click this deploy. Okay, the changes will be deployed and your Lambda function will be updated. You can go and use this test option. So it will run it, okay, and it will give you the result. Clear? So that's what the use case of this thing is. You can go, if you want to change it, you can go and say see it's given as products and we have given it as products, so that's why we haven't get any execution result. You can go and alter this to products. So once we changed it, we can go and click this deploy, and now if you test it once again, and we got our information TV, the answer in here in the body, it's working fine, okay. So this is how, so this is the code, and we have used a create a test function and it is working properly. So once you have learned S3, you can add a trigger to S3 and a destination. So whenever a file added to S3, you can actually do some task here in this code property, and you can give the output to a destination. So that's what about Lambda is. Okay, so once you created, if you don't want to use it, you can go and remove that Lambda function. So I'll just delete it. Close. Yeah, it's closed. Fine. So now coming back here, we are going to see some introduction about containers. So like, you don't want to worry about it. We are not going to use in this internship or in this master class, but I just want to give you a basic introduction about what is container is, what is Docker, what is Kubernetes, and what is container orchestration, and so on. Okay, just an information. So, and what are the options available in AWS. So this is like going to be a session, so we'll just learn about it. Okay, so we'll start with containers. So anyone have any idea what is a container is? In programming language, what is called as a containers? So when you go to the industry level, they talk about containers, container orchestration, and so on. So anyone have any idea what is a container is? Have you heard about Docker? Have you heard about Kubernetes? Have you heard about microservices? So the thing is, what is a container? Container are a lightweight and isolated unit of software package. So it's like a package that include everything needed to run an application, such as code, runtime, system tool, and library. And containers provide a consistent and predictable environment for software to run regardless of the underlying infrastructure. So the need for container is like previously, before the like invention of containers, what will happen is there will be software developers in the industry. So they'll create a software and it will be working very properly in their system. Okay, they will be having some configuration. Okay, it will be working very properly in their system, but when you go and like when they give it to client, it may not work properly. The thing is, this software configuration is different and their software configuration is different, so your app may run properly or may not run properly, right? So in such case, what they are doing is they have like used this container. So what this container will do is it will start from the scratch. Okay, so as a developer, you can like create or set some definitions. So these should be the configuration you have. These are the libraries, and it will be automatically installing when you like pack this container. So whenever you have this container, you will have all the OS, all the runtime, okay, all the libraries set properly, and your application code, so that whenever you run it, it will run properly, and someone else run it, it will run at that time also. Okay, clear? Is it clear, guys? What is this container is? And we can see actually a difference between what is a container and what is a virtual machine. So virtual machine, we will be having a hypervisor, and it is split into partitions. Or one user will be installing his guest OS, another user will be installing his guest OS, and another user will be installing his guest OS. And these things will take lot of space actually. So like for example, this guy may have some part of it empty and this guy needs some more, but they cannot use it, right? So something is lost here. So when you go for shared storage, you can go and use this container engine, okay, where this infrastructure is splitted, and you will be having this Docker containers where you will be just installing your bins and libraries, so the storage can be saved. So that's what the difference here. Am I audible, guys? Is it clear? Okay, fine, we'll continue. Sorry. So the container versus virtual machine. So here you can have this advantage and you can see this difference. What's the startup time? What's the disk space? You can see this is dedicated and this is shared actually. And this also gives you portability. So the virtual machine, when you compare the container, will have the portability, which means one thing is running on your system is also going to run on their system also. Okay. And the top container tool is something known as Docker container. You would have heard about it. So they are providing this service for containerize all the application. And do you have any idea about what is a microservices is? What is microservices? So microservices refer to a software architecture pattern where an application is built in a collection of small and independent services. So for your web app, there may be many parts to run, right? So if you have it in a single part, okay, if one thing fails, your entire application will go down and you may not figure out what is happening there actually. Okay, and you want to find out which is like going down, so you want to correct it and you want to make it correct so that your application will run fine. But what they have done is they have went and opted for microservice. So this microservice refers to a software architecture where the single application, they are splitted into small parts and independent service. Okay, it is splitted independently. Since a microservice architecture consists of units that run independently, each service can be deployed, okay, updated and deployed separately without affecting the other service. Okay, you'll be having different service, and these are Docker containers. Okay, they'll be having different application, different Docker container. They run coordinately to run a single application. So that's what a microservices is. So when you have a monolithic, which means it runs entirely, so this it takes individually, so they'll coordinately run with the microservice. So microservice can be achieved through containers, okay, by packing each microservice and its dependencies into separate containers. So you'll be storing them separately. Each container represents a self-containerized unit that provides the necessary isolation and portability to deploy and manage microservices effectively. Okay, you will just store them separately and make them run together. So now comes the question, how will they run together? You will be having different containers, so they will be installed and application will be there. How they are going to connect and run? So here comes something known as container orchestration. Okay, so something known as orchestration where you are going to make everything run smoothly together. Okay, clear till now? So when you go for container orchestration, it refers to management and coordination of containerized application across a cluster of machines. So container orchestration automates the deployment, management, scaling and networking of container. Okay, they'll just connect everything. And the top orchestration tool is Kubernetes. So Kubernetes, you would have heard about it. It is an orchestration tool. What is orchestration? To make all the Docker containers run smoothly and connecting. Clear? And when you go for Amazon, so with this, like for example, with this microservices and the Docker container and container orchestration. For container orchestration, we have multiple tools like Amazon ECS, which is called as Elastic Container Service. Okay, so this Elastic Container Service, also known as Amazon EC2, it's a container service. It's a managed service that allows user to run Docker based application packaged as containers. Okay, you can containerize it and make it run. Yeah. And we also have something known as Amazon Elastic Kubernetes Service. So this is like Kubernetes. Kubernetes is something like a separate application, but they have like made it for Amazon. It is called as Amazon EKS or Amazon Kubernetes Service. Same Kubernetes, but like tailored for Amazon to work with Amazon Web Services. So it also responsible for these tasks to orchestrate it. And if you want to recap, containers, they'll store all the information and regarding the application. So they'll like work on one system, they'll work on other system also. And if you have multiple containers to run a single application, it is called as microservices. And if you want to like how we are going to achieve it, it is achieved through container orchestration. Okay, so we don't have any work here with this ECS or EKS, but I'll show you what is happening there and why it is. We also have something known as ECR, which is known as Elastic Container Registry. So this is a repository. Okay, what is a repository? A place to store everything. Okay, you can store your files here. And what you can do once you have stored it, you can go and use either EKS or ECS for orchestrated Elastic Container Service. Here you can like orchestrate, you can create a cluster is like an application you are going to build, so you can create tasks where you are going to connect all the containers. Okay, so this is just for the information to enlighten you with this microservices. So here comes our today's topic, and we want to see it elaborately about data storage in AWS, because it is important, because from tomorrow's class we are going to start with machine learning. So we want to know everything about the data storage in AWS. So generally, what are the types of storage available? You have something known as block storage, file storage, and object storage. Okay, so like if it is a block storage, you have some differences. If it's a file storage, you have some differences. If it's an object storage, has some differences. So this one is stored as a block, and this one is stored as a file in your system, and this one is stored as an object in your system. For block storage, we have Amazon EBS. So if you remember, when we create EC2, we got something like, we have attached the 8 GB of elastic block storage, right? And we got 30 GB of free tier it. So this is a block storage where we have used it, right? We already used this elastic block storage in EC2 creation. And when you go for file storage, there is option known as Amazon Elastic File System. And when you go for object storage, we have Amazon S3. So Amazon S3, we have seeing it in past few days. It's very important actually. So this is known as object storage in AWS. And we have to know about some terminology associated with data storage, like availability, durability, consistency, and scaling. Okay. What is availability? So these are general terminology for data. So if you are going to store your company's data in AWS, you want your availability to be high. So what is availability? For example, this is like if it is 99% available, which means like in some cases this like the thing may go down. Okay, the website like we got some technical issue now, right? So something like issues may happen and it may go down, and you may not available. It may not available at that time, and you may like lose some access at that period. Okay, so what happened is, if it's 99% available means, so the maximum unavailability per year is 3 days and 15 hours. Okay, and if it's 99.19, it's like 8 hours will be lost. If it's 99.95, it's 4 hours lost. 99.99, 52 minutes will be go down in a year. You can imagine in a year. Okay, and if it is 99.999, 5 minutes will go down in an entire year. Okay, so what are the application categories? So these things you can use it. Okay, for ATM transaction and all, it is important, right? So you need 99.999% at that time. Clear? So this is known as availability, and this is the maximum availability. And AWS is providing 99.999% availability. And next thing is known as durability. So durability means like how durable it is. For example, if you store, and the Amazon, they are achieving like 99.119% durable. What that means is, if you store 1 million object, okay, you are storing in Amazon Web Service, you are storing 1 million object for 10 million years. In that period, you are expect to lose only one file. So these are human made things. There may be error. You may lose some file, right? Something may happen with the system and you may lose some files. It may go on like permanently. And this is the durability they are giving. If you store 1 million object for 10 million years, you would expect to lose one file at that time. And next thing is consistency. So today guys got about what is availability and durability. Can I get a confirmation from you guys? Yes. So next thing is known as consistency. So how consistent it is, which means like how synchronized it is. For example, you may would have sent some amount, okay, to like you have purchased, you are using GPay or Paytm, something like that. Like you have done it, but it is not updated in the server, which means it is not consistent. If it is happening 5 minutes late, whether it is consistent, not right. So you should avoid it. So the consistency refers to the state of data being concurrent and synchronized across multiple distributed systems. So when data is stored and accessed in a distributed environment, maintaining consistency is an important factor. So there is something known as strong consistency. Okay, strong consistency simply means the data must be strongly consistent at all the time. For example, in transaction, it should be consistent. Whether you have done it, it should be updated as soon as possible there. Okay, there is no delay. All the server nodes across the world should be contain the same value at any time. Okay, everywhere the server, if you change it, the information should be there. It should be changed. When you go for eventual consistency, so the different copies of the data may not be in immediate sync. Okay, there may be some delay or lag. So there can be a temporary difference between the replicas, a little lag, but over time they will all be consistent. For example, if you post something in social media, if you are posting, someone may else see it later, 1 or 2 minutes late, it won't be a big issue, right? But if you go for transactional application, it is very important to be consistent. But here it is not that much important. You may have this little lag, okay, just to get updated. Next thing is known as atomicity. So atomicity is a property of a transaction and database. Okay, it's like for transaction. So if I tell you in one line, okay, atomic transaction is like either all is done or nothing is done. Okay, it should be completed properly or nothing is done. So that's what the idea behind this atomicity is. It guarantees that either all the operation in that transaction are successfully completed and applied to the database, or none of them are applied at all. Okay. For example, if you are performing some money transaction, if it is completed entirely, then only it should be terminated. Otherwise, it should not happen at all. Okay, if you terminate it in between, you haven't completed the transaction, it should be stopped in between itself. And next thing is known as scaling. Okay, there is something known as vertical scaling and horizontal scaling, and these are just terminology. So if you have enormous need, if you have an enormous need of storage, okay, you are having some storage and you want to increase it, how you are going to scale it? There are two things. One is known as vertical scaling, where you will be increasing the size of the instance like RAM and CPU, etc. But when you go for horizontal scaling, you will be adding more instances to it. Okay, this is what the difference between vertical scaling and horizontal scaling. So we are just going to connect with other services. So if I go for this service, I'll tell you what their scalability, atomicity, durability and availability is. Is it clear regarding these four terms? What is available, what is durable, what is consistent, what is scaling? Tell me guys, is it clear till now? All the data storage terminology. Clear? Yeah. So I think we can start with this one, which is types of data formats. So we'll just practically go hands-on with this relational database, semi-structured data and unstructured data. Okay, we'll try to cover it. So whatever we can do it today, we'll do it, and the remaining things we'll try to cover in next class. So what is structured data, guys? Do you know about the types of data format? So we're having something like structured data, semi-structured data and unstructured data. So structured data has some structure like a table format with rows and columns, and we can use relational SQL database here. Okay, when you go for semi-structured data, it is in the semi-structured format, so it's not in the table format, where you will be having key and value pairs, and it is called as NoSQL databases. Okay, when you go for unstructured data, okay, if you have this unstructured data, it is something like photos or videos, you cannot categorize them into table or key value pair like photos, videos, or some files, etc. Okay, so for structured data we will be using relational SQL database. For semi-structured data we will be using key value pairs like NoSQL database. For unstructured data we can use either object storage, block storage, or file storage. Okay, clear? Can we start with structured data, guys? Structured data, we can go with relational SQL database. Okay, relational SQL databases. So to do this, we can use something known as Amazon RDS, Amazon Relational Database System. Amazon Relational Database Service is a managed SQL database provided by Amazon Web Services. So SQL is a particular language for this thing, right? So our database management. So it also helps with relational database management such as data migration, backup, recovery, patching, etc. When you go for scalability of this Amazon RDS, it allows you to easily adjust, compute, and handle changes workloads efficiently. Okay, so there won't be any errors or failures. So this is what they are assuring. Okay, RDS automatically replicates data across multiple availability zone to ensure your data is protected. And like for example, if one AZ is go down also, if it is durable, okay, and if it is available, you can have it from some other AZ. So whatever changes you have done will be have a backup and you can get it properly. And regarding the availability, RDS provides high availability through features like multi-availability deployment, which replicate data synchronously. Okay, so ensuring resilience and minimum downtime. So these are the things they are ensuring. So I think we can go with a hands-on, and we can complete today's class with Amazon RDS hands-on. Can we go hands-on, guys? So let me go and search for RDS, which is Relational Database System Service. We'll wait for it to complete. Yeah, this is the dashboard. So you can go and click this create database, or you can go with the database. There is no database right now, right? You can go and click this create database. And let me go with standard create. Am I audible now, guys? Sorry guys, there have been some network issues, and I think we cannot continue further. We'll try to see it in tomorrow's class. Okay, sorry for the issues, please apologize. We'll try to see it in tomorrow's class. We'll continue with it in tomorrow's class. Thank you, guys.